Hello again, Roland O'Flaherty, Robotics PhD candidate at Georgia Tech. Last week I showed you how to write code directly onto your BeagleBoom Black using the Cloud9 IDE that's being served up by your BeagleBoom Black. This week I want to show you how to expand on that code so that you can actually interface with those GPIO pins to read sensor values or write commands to, say, motors. All right, let's get started. So the first thing that we have to go through is what do all the pins mean on the BeagleBoom Black? So on the BeagleBoom Black, there are two headers, sets of pins. There's P9 and P8, and each header consists of 46 pins. Now, these pins have special meanings. For example, the ones here on the P9 header are used to provide certain voltages. For example, 3 volts, 5 volts, and ground. These pins over here can be used for digital reads and writes. So these are general purpose input-out pins that can be used for reading and writing digital values. And for example, these pins down here are your analog read pins. So these can read in analog values instead of digital values. So one thing to be cautious of when working with the BeagleBoom Black is it actually operates at 3 different voltage values. So the board itself runs at 5 volts. The GPIO pins operate at 3.3 volts. And the analog to digital converter pins operate at 1.8 volts. Now there are 2 pins here that are used to operate at to give out 1.8 volts that you can use for your analog to digital conversion. So let's move on. So the circuit that you'll be building today is shown here. It's a simple circuit. What you'll be doing is reading in a digital value and writing a digital value. So you'll be reading a digital value from this button here and writing a digital value out to this LED. You'll also be reading in an analog value from this potentiometer and using that to control the brightness of this LED. So on the diagram here, you can see all the wiring and the pins that you have to connect this circuit to. So go ahead and put this circuit together if you have the components. So a potentiometer is a device that it basically acts like a variable resistor. I have one here. And so as you twist this, the resistance across these terminals changes. And what you can use this for is as a voltage divider. So if you put in, say, 5 volts on one end, say you put 5 volts on this guy and ground on this guy, the output that you get from this middle pin will be linear proportional to wherever that dimming knob is. And that output voltage then can be read by your BeagleBoom Black to determine what level you want your LED to be dimmed at. A push button, obviously that's pretty simple. When you press the button, it connects these 2 leads here, otherwise it leaves them open. And an LED is basically, so those stand for light emitting diodes. And the only thing you really have to know for these is that it's a diode. It only allows current to flow in one direction. So you have to know which one's the anode and which one's the cathode. So current flows from the anode to the cathode. And on the LEDs, they're always marked with a flat end. That's the cathode. That's the negative side. Or the longer pin is actually the anode. So that's one thing you can use to distinguish how to hook this up. So go ahead, hook up your circuit there. And another thing to be aware of, so with most microcontrollers or microcomputers, they actually don't output an analog signal. They don't have what's called a DAC, a digital to analog converter. Instead, what they use is what's known as a PWM, or pulse width modulated wave. And so a PWM, what it will do is you can control, it's a square wave, so it's either at 1 voltage or at 0 voltage. Here, the BeagleBoom Black uses this voltage at 1.8 volts. And what you can do is you can control this, what they call the duty cycle, so how fat this wave is. And it will repeatedly produce this wave in a periodic fashion. And so then what you can have is this, you can low pass this if you want to actually get a analog signal. Or what's commonly used is this allows for, since this has different widths, what's really going on here, say with an LED, is it's turning on for a certain amount of time and turning off. And since it happens so quickly, it looks like it's just on. So if you make this width shorter, it will look dimmer. If you make it longer, so down here, say if it was this long, it will look brighter. So that's how we control the dimness of the LED. So let's go ahead and program this. So I'm assuming that you've created your circuit there, if you want to buy the components and do it. And let me go through the code. So let's switch over to our Cloud9 IDE here. And let me go through the code that we're using to read in these values and write out these values. So again, like last time, we create this BoneScript object that has all of the methods and properties we need to interface with our BeagleBone Black. And then what we're going to do is we're going to set what our analog LED pin is. That was set at so P813. And we're going to set what our digital LED pin is, so that's P814. Our button is P819. Our potentiometer is P940. And we're going to have a value that's stored for the current state of the button and the current value of the potentiometer. And we're going to just have a run flag which tells us to quit after 60 seconds here. So we're going to set our LEDs as outputs and our button as an input. We're going to set a timer, so after 60 seconds this function called stop is going to run, and what stop does down here is just change that run flag to false. And then we're going to enter this loop. So inside this loop function here, we're going to read our analog value, so that's just done with an analog read. So it looks for that pin there, we set our potentiometer onto that pin. And then we're going to read our button value, so that's just a digital read, and looks for the pin that our button was set at. Then we're going to write, so that's just an analog write, so that's going to write not an analog wave, an analog signal, but remember a PWM. So we have to give it the pin to write to and the value. So we're going to give it the value that we're read in from our potentiometer. Now this analog read doesn't give you the actual voltage, it gives you a percentage between 0 and 1.8 volts. So for example, here's some output that you'll see. When it was read in, it was almost 0, and then if we had turned the knob all the way up, this would be 1. And for our analog write, what we do is we write a value between 0 and 1, and that's that duty cycle, which is a percentage of the entire wave. So if it was 1, that means the wave is on all the time. If it was 0, it's off all the time, and it's 50%, it would be half up, half down. So then we do a digital write, and we write the value we read in from our button and use that to write to our digital LED pin. And then we're going to display our results to the console, and then we're going to check if we want to continue to run. So if this is true, then we'll go back to this loop. So let's run this and see what happens. So we'll come up here and go to run. So now this is running, and I have the circuit set up here. So when I press this button, the red LED comes on because it's reading the value. And you can actually see in the output of the console, the button value changes from 0 to 1. Then if I change the potentiometer, we can see that the green LED gets brighter and dimmer as I change it. And if we look at our console again, we can see that the value is changing between 0 and 1. So that will run for 60 seconds. So what you can do now is you can actually use these same function calls in your BoneScript to read in different types of sensors. So you can read IR sensors, for example, or a temperature sensor. And then you can actually write to different to control different types of things. So you can control LEDs, you can control motors, you can control brightness of other lights. So yeah, there's a whole bunch you can do with just reading in digital values and analog values. So next week, what I want to show you is take it one step further, where we actually read in, instead of single values, we're going to read in strings over what's known as the serial line. So that's from a UART, that's a device on the board, or I2C, which is a protocol that is commonly used in sensors. With knowing that set of tools, you'll be ready to go to do all sorts of projects and interface with all sorts of sensors and actuators. See you next week.